These intermediate winches, normally capstan or caterpillar, it requires always a method of synchronization to avoid that this instrument puts some extra strain in fiber because of difference of the speed. Imagine that we have here some speed, and we have here another speed. If these two speeds are not well related, we can have more speed here than here, and the fiber in this portion will be strained because of the two pullers. Then that's the idea. We need to have some synchronization and between the speeds that are applied in intermediate puller and the speed that is applied in the end of the section that are being installed. Also, it's very important to avoid knots in lines or hoops. It seems to be easier, but when we have long lengths and we have several people involved to have some problem and people put knots in the lines or in hoop, it could help the speed of the work, but could also give some problems to the cable. Relative to the guiding systems and cable bending, the main recommendation is to use as a minimal bend radius 2 times the cable diameter, 2 times the diameter external of the cable. If the cable is in a high level of tension, of course, less than the allowed, maximum allowed, but some way more thinking like a high tension, is better to use in this bending radius criteria to use 24 times the external diameter of the cable. And it's applied for each curve that the cable will be during the installation. Not only respected to the guiding system, but here we can consider as guide system each place that helps the cable change direction. Then sometimes the guiding system is the guiding device is a special device, but all the curves or bending we have in this way, we need to consider as part of guidance system. The idea is to look to the cable. If the cable is bending, there is a point that we need to take care. Another point that's important, that's the cable friction and lubrication. Special attention must be given to this point when installing optical cable, as this friction force, they need to be overcome, and there is a lot of factors involved in that. Most of them refers to the kind of duct, but some to the kind of finish that the cable sheet has. Then it's necessary to know what information we already have, and if it's not enough to take care getting more information about the cable friction and lubrication. When we need, in some occasion, long length, there is some methods that allowed us to use these long length cables installed by pulling. Sometimes, or most of the times, it's not possible to do this using a single end pull method. And then it's necessary to have some strategy that can include static methods or dynamic methods. The most useful static method is what we call figure of 8 system, and in dynamic methods, we use sharing of the load. The figure of 8 involves that the cable drum is placed in some intermediate place, and some part of the cable is removed and put in a form and shape of figure 8 in floor. And after that, the part of the cable is pulling, considering the portion that are in the drum, and other is installed considering the portion of the cable that is in this figure 8 form. In this way, we divide in 2 or more if is necessary the amount of cable to be pulled, and using this way to put the cable in some intermediate position, we reduce the length of the cable that will be pulled. In dynamic load sharing, we use cable winches in some intermediate points, as shown in the figure we discussed before. And in this case, it's necessary more equipment, and also it's necessary this synchronization, especially some good communication and between this point in the middle of the way of pulling the cable. It's necessary to take care, especially if we use capstan, because sometimes this kind of device could twist the cable, and it will be not good to the fiber inside the cable. If someone use hand pulling methods, it's possible, and in this way, sometimes we can put several hand pulling people acting in the middle of the way, and all of this restriction to minimal bending and to tension must be applied for every one of these people. Then it's necessary to have a good information, because in some occasion, the people that are doing this kind of work, they are aware of the difference between optical fiber cable and other kind of cable, especially metallic cable, and sometimes not. We need to take care about the people that are doing this operation. Another way to do this is to apply induct cables that are installed using air-assisted equipment. Then, in this kind of device, there is a continuous and high-speed airflow that push the cable. And one of the advantages of this cable installation method is that the load on the cable is one order of magnitude lower than pulling techniques. It's a big advantage, of course. And also, in this kind of method of installation, the bands and ducts, they are not so important as pulling techniques. Of course, there is a restriction of the minimal band radius, but in other case, when we have tension in optical fiber cable, the effect is higher. The effect of the bending is higher. Another advantage of this kind of method of installation is that increases the installation speed, and also it's possible to install long length of cable. In this method, cable are installed without virtual stacks. Then the cable is relaxed in the duct till the completion of the installation. And different kinds of cables that exist in the market result in different kind of system developed to install optical fiber cable in underground ducts using air-assisted device. Then there are system and devices special for bundles, for cables or fiber, and also for special kind of cable. There's some fiber directly in tubes or ducts. Then we can put, using this kind of system, we can put one or few fibers. We can put a bundle of fiber, or we can put a tube and install using this kind of device. There are two processes that, technically speaking, they call two-pass process. That is more adequate for microduct or bundle of fiber. In this case, for 4 to 8 fibers. And there are also a second system that's more likely to be used in normal cable blown. These two-pass process use the idea of install first the tube, and after that put a bundle, the fiber inside of these tubes. And the idea is to have the first operation, that the tube installed, and normally it's used a bundle of tubes that's normally called microducts, and it could be loose tubes of microducts or construct as a cable. After this step, we have the bundle of fiber put it into the microduct in a second step. Then these fibers are blown by compressed air. And this bundle of fibers, they are just as small as 2 millimeters in diameter for 4 or 8 fiber, or it could be also big amount of fiber, such as 96 fiber cables, in this case with diameter around 7 millimeters. The speeds used are around 2 kilometers an hour, and during this kind of installation, the fiber experiences little or no strain, and this kind of installation could allow that cable up to 10 kilometers be installed without intermediate splice. The other method is normal cable blown, and this method, optical fiber conventional, they are blowing in small pipes or ducts. Of course, this success depends upon the cable characteristics in terms of diameter, weight, flexibility, and also depends of the duct diameter, and also depends on the friction between the cable and the duct. Depends also in the number of curve of overall duct room. It's possible to put length of 500 to 1,000 kilometers. In this case, there is no synchronization problem, and the speed of the installation of the cable is around 2 kilometers an hour too. If we need install more than this, or if we prefer too long length, is better to use lubrication of the ducts. And also the cable, it could be contain a cable lubricator with RPS. Then we can apply a lubricator in the cable, because the idea is to move the cable just using the airflow. Less interaction we have between the surface of the cable and the outer surface of the cable and the inner surface of the tube, better will be the process. Then the idea is to try apply lubricator or in duct or in cable or in both to get more success in this kind of installation. Another system that sometimes is used is a system that uses water pump system. Then instead of air, we use water to be a floating effect in the cable. It force the cable along the route. It's shown here. We have the drum and we have the cable, and here we have some equipment that put the water with inside the conduit and move the cable. In another side of the pulling length, we have the other tank equipment. And the typical speed of this process could reach 30, 40 meters per minute, and sometimes is used also a parachute or a piston that is attached in the end of the cable just to improve the cable movement. Then we can have a cable just move it by the water flow, or we can put a piston or a parachute in the end of the cable just to have some surface that receives this flow and help the cable movement. Again, bends along this cable route are less significant than in pulling techniques. It's always important to remember the minimum radius could be an effect, could have an effect in the lifetime of the cable. If we have tension at the same time that we have some bending, and it's more critical. In this case, the curves and the bending radius that we have in each part of this is the same of the duct if there is no water. But this reduction of effect is caused by because the fiber is almost free in tension. Then we have this complication of bending plus load. This is a detail of the equipment that used on the end of the cable. Then the idea is to have the cable put it in his way using a caterpillar, and there is a coupling device when we mixture the cable and the water from the pump. A good effect is that this water flow does not cause the increase of duct temperature. If we have some air and some force, some pulling without air device, just pulling normal way, sometimes this friction of the cable against the inside wall of the duct could cause increase of duct temperature. In case of water, it's not doing this effect because the water flow does not cause this effect. Because the water assists the passage of the cable through the duct, and act also as a lubricator. As it's easy to use a small, because of this it's easy to use a small gasoline power pump to install 1 kilometer of cable in minutes. And some long length of cable of several kilometers have been installed using this method. One important point is that when the cable is installed in underground duct is to make the proper arrangement for an extra length of cable that allow the access for joining or for testing. This additional length is generally bigger, it's greater than the used for metallic cable, and this could not be used, in this case, could not be used that part of the cable that was used in attached to the rope, and it's necessary to cut the portion of the cable that was attached to the rope that was responsible for the pulling of the cable, and leave some extra length of a fiber that's out of this end portion. As we will move to another kind of installation, I'd like to know if there is some question or some information you want to discuss. As I see no question, I will move ahead. But anyway, if someone remembers some point that wants to discuss, you can do this later. Yes, sir. This one? This one? Yes, of course. The question is about this relation between the extra length that's mentioned in this paragraph. It says here that additional length in case of optical cable in each of the ends of the cable is normally greater than that allowed for metallic cables. And the idea is that we have more needs to be done in optical cable than in metallic cable. Then sometimes it's necessary to do some measurement using equipment that sometimes is difficult to put just near the point where the duct is terminated. Sometimes the equipment is on a car or a van that's necessary to put the fiber in this. And also it's convenient to have an extra length in these intermediate points and the final point to be used in the future to some measurement or some extra splice. That's the idea. Because in terms of metallics, sometimes 1 meter could be enough. And here in optical fiber, it's recommended to use for 3 to 5 meters and to look carefully at that specific point. Imagine that you have some difficulty in reaching this point because there's some obstacle here, and the people that will do the optical measurement arrive there and need to put the end of the cable in some optical equipment. Then it's better to have 4, 5, up to 10 meters of cable inside of this point, and to have facility to use if necessary. because if not, you need to take care, because sometimes people start to pull in the cable to have more extension in the end. Then the idea is to get the cable and to leave some extra length, okay? And this need to be a good port from 5 to 10 meters most of the time. That's the idea. It's okay? Yes, sir. I can go to you. Mine is near.
Thank you. Could you go back to the optical fiber cabling in underground duct about the tension control? No, I don't remember the number of the slide, but it's on 1.13 something. Yeah, 1.1.3. It's about the tension controlling system. Yeah, there. I didn't quite understand how reliable is the tension controlling system, and how is it placed as far as the distance is concerned from the cable drum position. Do you have specific distances where you have to test to measure the tension, and is it really reliable for one who's doing the installation to make sure that there is no problem afterwards?
Thank you. The principle involved is that the higher tension that the cable have is at the end of the cable. Oh, sorry, this is very fast. Here, that could be both. Could be a system that really control, okay? If it's a system that control, he needs to control this portion and all the portion we have in the middle. That's the best case. And in this case, the idea is that as the cable goes through the duct, the higher tension will be at the end of the cable, okay? Then controlling this tension, we are controlling the higher tension that the cable are suffering. That's the idea. Because you need, as we have the puller, okay, that's the idea. If it's a system that control imagine you don't have this. Imagine you have just the cable and the puller here in a system controlling. Then the operator could see the tension. If the tension goes up, stop the pulling and investigate what is happening. Because sometimes it's some obstacle that the cable found in the way. And the idea is to stop when the tension reaches some high level. Some high level. That's the idea. In the second way, if we have some system controlling not this, but this intermediate puller, we need to have also sometimes information of this puller. But most of the time, what they do is synchronize the speed of these two equipment. Then if they stop, both will stop, and all the time the people is still still seeing the maximum load and controlling the system. But it's possible also to have here a maximum tension that the system stop automatically, or reduce the speed, or do some action. That's the idea. Then just resuming. First, this is the point that we need to control, because it's the higher tension the cable will suffer. Could be controlled by operator, just looking the values. It's very important to have a register of this, not only visually, but you can have a graphic or some program at the computer that install this, that accumulate this information. If there is no an automatic system, the operator could do some action. It's very practical to establish some limits just below the maximum allowed tension. Then we can put some alarm at 60% of the maximum tension or less, just to have time to correct anything is necessary. The first action is not continue pulling the cable if the tension is increasing. Another way to use this system is to measure the speed of inclination of the tension. If this tension is just in some stable level, it's okay. But if the tension starts going up, it's not necessary to expect to wait for some higher point. The system could act before, just because it noticed that the tension is going up. Then there's a lot of ways to use this. Related techniques. Most of the times when we deal with the mini trench and micro trench, some of observation that I've done here in 1.2 will apply. I didn't put, because it's not necessary to repeat. But most of the time when you went to the 1.3 and 1.4, we will deal more with the difference between this optical cable installation with trenchless technique. There is a specific recommendation about this subject, is the L38, and part of this information is part of what has in L38. Then if anyone is interested in this subject, it's better to consult L38 too. Here is just to give you a general view. Okay, first important thing is that this trenchless technique is also called no-dig techniques. These techniques allow the installation of underground optical cable, minimizing or eliminating the need of excavation. Then the idea is to put the cable in a horizontal bore below the ground, and in this bore, the underground infrastructure, the ducts, the pipe, or direct buried cable can be placed. The idea is to have this boring, but what we want to that part of our network. These techniques has some advantage with relation to environmental damage and also to social damage that each time more represents costs. And this way, it's an economic alternative to open trench methods of installation. When we have open trench, we just put people or machines open a trench and put the cable inside. In some occasion, it's important to have a way to do this with another kind of device that could do this horizontal bore below the ground without excavation. There is 4 main types of different techniques. As the handbook didn't go in detail in this technique, will go in detail too. And of course, the main description you can find in this L38. But they have some difference that I will try to explain. There are some specific name, pouring time, excavation, and slurry discharge type, excavation with auger type, and press-in type. And we'll come back to this comparison a little ahead. Let's talk a little more about this technique. There are some specific points when it's good to use this kind of installation. The first point is that when excavation at all the length of the cable, where the cable, all the root or some parts, when there's some limitation or restriction or prohibition, normally done by administrative agents. Then we can have a newly constructed road that the people don't want to have a trench, that new road. And sometimes we have emergency vehicle entrance or exit. That's not a good way, good idea to have a trench there. Some could happen in this time, and this emergency vehicle could be affected. Then there's a kind of reasons to use this kind as this technique. Another reason is related to the risks that trench could represent to the traffic or to pedestrians. Then when we have some part of the route that a trench could be affect the safety of these two, the traffic or the pedestrian, it's better to use trenchless technique. And also there are some places where noise, vibration, dust, and other pollution could be, needs to be avoided. If you are near a hospital or you are near some place that are some very important people, sometimes they don't want to have this. And there are also some locations related to instruments, some laboratories related to measurement that could be affected by this kind of vibration. Then when the company trying to get the approval could find some problem in get the approval of trench in this region. The open cut also could sometimes hinder the business of someone, especially near store. Then the people has some restriction related to this. Sometimes that restriction could be exerted by the administrative agency, or other times the company, the telephone company, don't want to have this bad image with this, their names. Okay, if you put a trench and put some information about the company, people could relate one thing to other, and in some places it's it's better not to do this. Another reason could be take care of the part when we have a lot of facilities of other companies. Then if we have some sewer, electrical ducts, sewer ducts, or other telecommunication company, could be a big risk to do a trench and affect this other service. In this case, just doing some information in advance, it's in any case, when you have this kind of techniques, it's necessary to investigate the soil. And then with a good investigation, we can find where are each one of these other companies do, and find a way to pass there without affecting the other facilities. Another reason is when, for any reason, the ducts must be buried in a deep location. Then the open cut construction will be almost, it needs to be at this deep location, could be a problem to do these, and could be easier to do the use of some trenchless technique. Another reason is that some roads have some protection, what we can call high-grade material. Then the cost of the restatement after excavation, that's the company needs to cover. It's could be one of the reason to use a not to do an open cut method. When we have also the high traffic volumes, sometimes it limits the work to the nighttime hours, and it causes some lack of the work efficiency and also some labor cost higher than normal. And finally, in some places that are old, it's frequent to find some historic remains, and the cost of dealing with this and also the cost of removing these remains could be excessive to the company, and the company prefer to have a trenchless technique. That's a large list of situations. Of course, there's a lot of other situations that we can imagine the advantage of this technique. And this is a figure that shows what we are talking. Then we have this is the way the bore path. We have here a machine that will guide the element that will do the bore. In this example, there is some existing facility. Of course, the investigation showed the position of each of these facilities and the route established in terms of length and depth is necessary to avoid and to reach the other point. That's the idea. Some special application improved the technique used and also contributes to the large use of this technique. The first was the necessity of cross river and railways. Then if here instead of houses and buildings we have a river or a railway, it's impossible or not so easy to do this with other kind of techniques. Then it's easier to pass just under the river or the railway and reach another side. The urban environments also are very attractive to the application of this technique because it's possible with this use avoid or drastically reduce a lot of troubles that the drawback or the open cut method could cause. And some case long distance lengths could be achieved of several kilometers if there's a division by some or enough number to cover 100, 200 length. Then if we need to cross more than 100, 200 meters, the idea is to have section and still doing the bore. In any of these cases, soil investigation is very important. It's necessary to know the position of all buried objects of interest and also the nature of the ground. It's necessary to optimize the path, the drilling path, and also to avoid the risk of damage the existing infrastructure and the equipment. Then we need to know what the drilling equipment will find in terms of natural elements and in terms of structure built by man. It's essential to do this way to succeed. Before moving to the next kind of trenchless technique, Any question about this? Yes, Mr.
Thank you. I've seen in the manual that there is two kind of trench. Okay, let me just ask the question. Maybe you'll know if it will be in the next. Or is there any recommendation or any standard about the deep of the trench?
The question is related to the depth of the trench. We are sometimes the name of it refers to the mini trench and micro trench, and the main difference is not the depth. They are always used around. There are two kinds of normal trenches and one different that's called micro trench. The first two, they are around 30 centimeters deep, and what changed is the width of the trench. One you have around 10 centimeters, another is almost half of this. Okay, but sometimes, and it's good not go so deep. Then they put this in what they call micro trench techniques. And roughly, in the first two cases, we just pass the asphalt barrier and goes to the soil and put the cable in the soil. In in around 30 centimeters. If someone wants and have some good condition of asphalt, you can put the cable just in the asphalt. And that's what they call the micro trench techniques. And the micro trench technique is to put the cable inside the asphalt layer. And the mini trench techniques is to have a mini trench, not equal they used to dig with machine or man, that's larger, and always to have around 30 centimeters. This appears because there was some problems, some difficulties that these techniques decide to try to solve. Of course, in a different circumstance, could be different measurements. Just to give an idea, sometimes in some place, mainly in Europe, it's almost impossible to do the open cut method. Then the people start to doing faster, using the machine and doing mini trench. And after that, when the fiber start going to near the customer, especially FTTX networks, the streets doesn't go to the client, to go to the home of the people. Then they start to use micro trench techniques, okay? Because even in some place near condos or near a lot of houses, we have passage for pedestrian, and someone are with asphalt. Then they start putting this to reach some point, and after that, distribute the fiber to different homes or apartments. And it was the reason they put mini trench here. And in some place also, like in Italy, it's very hard to walk in downtown. Then imagine what the difficulty of people to install fiber. Then it's very important to change the environment the less possible, and micro trench was a solution for some case. It's give you a general idea. Yeah. If there is another point, you can discuss again. Okay.
Okay, like in our country, we have rains, we don't have roads which are all paved, and sometimes with rain, the soil is can go, and if you do micro trench, this will be yeah, yeah. So so I don't know how deep we can go to protect the fiber.
There is some possibility to use the one or other techniques in any place. And the important point is how controlled is the soil. That's the idea. You cannot have a lot of stones under the surface, because it could be a problem. You cannot go this way all the time. And you cannot have a soil that changes because of rain, because of a lot of other circumstances. Then if we have this kind of soil, maybe the best could be use a buried cable with more than 70 centimeters up to 1 meter. I saw some place that the people use 1.5 meters. It's a lot. It's this high. Or put ducts, because we have this situation in country. In Brazil, we have this situation mainly in optical fiber installed in roads, in highways. And sometimes we have the soil moving, and we have a lot of pictures of this. What we have is the duct on the air, because the duct resists, and all the soil was removed. Then they have time to arrange the situation, to move the cable from one to another point. But if we have just the cable buried, in this case, certainly the cable could be gone with the soil. Then one way to do this also is to take careful about the route that are being used. Sometimes the shorter distance between 2 points is not the more trustful route. Then it's better to find another soil near but more trustful. And I saw it depends on the administration authorization. In at least one occasion, I noticed some company that installed the fiber in the middle of the road, deep in the middle. Just when we have the line to not cross, and it was in a place that there's a lot of soil disarrangement in both sides, but they noticed that the road was more stable. And then they got some authorization to put the fiber just in the middle of the road. It was the distance more, not so near both sides. Then, of course, what we are discussing here, what we discuss now is more personal experience than recommendation. Then the point is that the recommendation moves to reach the necessities of someone, or most of the time, a lot of people. And recommendation, most of the time, like you can see in the pictures at the handbook, they were proposed by people who solve the problem and decide to share the information. Because it's the way, sometimes, if you have some specific, it's advantage of ITU. If you have a specific problem, then use a different method of installation. This problem is solved. You can propose some modification in the recommendation, the existing recommendation, or also propose new kind of recommendation for different kind of cable. Because most of the time, the situation is not the same in every place, but same situation occurs in a lot of places. And sometimes one that has more opportunity to solve the problem, share this information with a forum like the ITUT, and others could know more about this. It was the case of these three techniques. They appears because of some problems. The people decide to manage the situation and find a solution, and after that send information as a contribution to the people that deals with the installation of optical fiber. This one in the past was in study group 6, and now it's in study group 15. Do you want to?
So you will have a presentation here for that with a map and the main projects. I will ask maybe to the press and so on to be ready because we start the formal official opening for local authorities. Thank you. Il arrive.